Hello once again, my lovely G11s and G12s. Your favorite uncle is back with a bit complicated simultaneous equation. We all know simultaneous equation. They give us a quadratic and maybe a linear. They give us a quadratic equation or a quadratic solve for x and a linear solve for x. We see C solve for x and y. So but this one I'm gonna to my lovely G11s and G12s because I can see inekuba complicated nyana ngale square root and this side basithiye khona bacabanga ukuthi silibele kanti nesihlakaniphile sima-maths pros angithi. So this is very easy for my maths pros, my lovely maths pros. 3 to the power x, 9 to the power y is equals to 27. But easy this side. So we'll first have to deal with this complicated one. How do we solve this one? Just like on our previous content, when there is a surd, you first isolate the surd so that mobile said ngiyelo complicated into. So you first isolate the set, and on the previous one we were dealing with the one with solving for x on an exponent. Now mind you, let's solve for x, both for x and y, they are on the exponent. So and there is a sad shothi le seyihlanganisa our previous content and our previous one where besifunda solve ama exponent x and y mawubaba kuma exponent, then our previous one we said sekusho ukuthi nyalo le seyihlanganisa konke. So let's see how do we deal with this complicated one. Okay, we'll deal with this complicated one this side, and this one maybe if we have to simplify it we'll look at it this one, but let's start with the complicated one. How do we solve this one? Okay, it's a root of 3 to the power x multiplied by 9 to the power y. 20 is equals to 27. But if we look here, sibona 3 and we know what's 9. 3 to the power 2 gives us 9, right? So 27 again, 3 to the power 3, it gives us 27. So they thought maybe it was shy, but lendo is obvious. This 3 nala siyakhona kutshintsha kubeng 3, nala siyakhona kutshintsha kubeng 3. Why is tshintshe sise kubo 3? Because we wanna eliminate these exponents, right? Because to deal with exponents, all the bases must be the same. That's when you can attack exponents. So all the bases must be the same. Let's change all these bases to be the same. So that's our first step. Okay, okay, 3 to the power x, we just want to reduce these ones to 3. So we know what's 9 is 3 squared, right? So we put our bracket. For the 9 we put 3 squared. 3 squared gives us 9. Then we close the bracket and put the y outside. We don't put it inside here to show that the y low was the whole thing. So it's equals to, okay, we know 27, 3 to the power 3, you can test it on your calculators. 3 to the power 3 gives us 27. So okay, let's go on. We just want to again 3 to the power x multiplied by, when it's like this you just multiply the exponents. So 3, 2 times y is 2y. This will be 3 to the power 2y is equals to 3 to the power 3, right? So again, you remember Mastilang Masat, what did your favorite uncle say? When there is a set, you first have to isolate it, is said, so that you can use a square to eliminate the set. So we cannot use a square now while it's both there here. So let's isolate the set. How do we isolate the set? We just do like this. 3 to the power x is equals to, here we have 3 to the power 3. But remember, this 3 to the power 2x was multiplying this side. Whenever it goes to the other side, it's going to divide. So we do this, 3 to the power y, we put it here. 3 to the power 2y, we put it there, right? So manje sesiyakhona kuyibona we isolated the sad. We want to eliminate the sad. How do we eliminate the sad? Your favorite uncle showed you on the previous one. You just put a square, right? But what you do on the left, you also do on the right. Meaning we also have to put a square here, right? So this one eliminates this one. On the left, we are left with 3 to the power x is equals to. When it's like this, it's the same thing as 3 to the power 3. And squared. You see, this square is outside the fraction. Meaning the square list is for both this one and this one. So divided by 3 to the power 2y close bracket squared again. This is the same thing as this. Why do we use a square on top and on the bottom? Because this square is outside and belongs to both the numerator and the denominator. So let's see which is is equals to, okay, here on top we want to remove the bracket, but I showed you if it's like this, you just multiply the exponents. 3 times 2 gives us 6, meaning it's 3 to the power 6 divided by 2y multiplied by 2 gives us 4y, meaning here on the bottom we now have 3 to the power 4y, right? So, but as you can see, manje, things are easy because all the bases are now the same. So let's take this 3 to the power 4y back to the left. And show our AMC is an isolator, stochastic eliminator is that. So we did that. Our 3 to the power x is now alone. We are allowed to take the 3 to the power 4y back to the left hand side. So it will be 3 to the power x. Because it was dividing this side, when it goes to the other side, it multiplies. So 3 to the power 4y is equals to 3 to the power 6, right? So when it's like this, you remember your favorite uncle showed you if the bases are multiplying, meaning we can use the common base, but my exponent, we put a plus sign. So it will be 3 total of x, because it's also 3 here and they are multiplying, we use a plus sign. Then we can take the 4y, then it's equals to 3 to the power 6. You see? So now, okay, this is the same thing as this. So now we can see the bases are the same and we have these exponents. But if the bases are the same, we just drop the bases, we take the exponents as they are. So x plus 4y is equals to the 6. You see how easy it is? It was just looking complicated here, but it's very, very easy. So as we can see, we simplified this one into this form. So let's go to the other side. What do we do on the other side? Is there anything difficult you need to deal with here? I don't see anything difficult. What I see, would see here, let's form our equation 1 and make x the subject of the formula so that we can use it here on this x. So for equation 1, we'll isolate the x so that you can go solve it simultaneously there. So x is equals to the negative 4. The 4y will go to the other side, becomes a negative 4y plus 6. You see, is our equation 1. So since we have equation 1, say we'll call this one our equation 2, because we want to take equation 1 into equation 2 to solve it simultaneous. Then we say equation 1 into equation 2, right? So equation 1 into equation 2. So let's see, wherever there is x, we say x is equals to negative 4y plus 6. Wherever there is x here, we put this. Actually, we are solving simultaneously. So x, wherever there is x, we put the minus 4y plus 6, right? Then we take it as it is. Here is our 4y squared is equals to 6, right? Hope you understood here. Would see your favorite uncle just removed this x with this part of this equation, which is negative 4y plus 6. Why? Because this shows that x is equals to this, meaning we're allowed to remove this x and use this one. So now we have a simple quadratic equation here, right? So we just have to rearrange it so that it toba in the direction is going to go. So we say 4y squared, and there's no like term for the y squared, but we have the negative 4y, then we have the 6 plus, okay, 6. Then the 6, this side is positive, meaning when it goes to the other side, it becomes negative. Negative 6 is equals to 0. Then we have this one, and let's see, which is starts is bigger, 4y squared minus 4y, then 6 minus 6 is 0, right? Meaning this is equals to 0. So obvious, when we have it like this, we now know we just have to factor out the y, then y, open bracket, or you can even factor out 4y, but anyway, it's the same thing. So we factored out the y, then we are left with 4y. Y times 4y gives us the 4y squared minus, okay, we put the 4 is equals to 0, as you can see. Then when it's like this, we now know that y is equals to this 0, and 4, we take this one as it is, the law of factorization. 4y minus 4 is equals to 0. So this one is not yet finished, so we have to solve for the y. So we know that it will be a 4y. The 4 is negative this side, we take it to the other side, it becomes positive. Okay, now so we want to isolate the y to know the answer. We divide both sides by 4, because there's a 4 here which is disturbing our y. We divide by 4, but what you do on the left you also do on the right. Divided by 4, then we now know this 4 cancels this 4. We now have y is equals to 4 divided by 4 gives us 1. So we now know that y is equals to 0 and 4 and y is equals to 1. So we now have the two answers for our y. So let's come here and solve for our x. So when y is equals to 0, let's see what do we get for x. Remember, we have an equation for x. We just have to solve and put 0 wherever there is a y. X is equals to negative 4. We take this one, our y, but we have y is equals to 0. This is 0 plus 6. Then x is equals to negative 4 multiplied by 0. It gives us a 0 plus 6. We find that our x is a 6. Then when y is equals to 1, you see, so we again come to our x. Again, we want to solve for x. X is equals to the negative 4. What is our y? Our y is 1. Then plus 6. Then x is equals to negative 4 multiplied by 1 gives us a negative 4 plus 6. We now know negative 6, negative 4 plus 6, that's a 2, right? If I'm not mistaken. Meaning we now know that when y is equals to 1, our x is equals to 2. When y is equals to 0, our x is equals to 6. So your favorite uncle was just showing you how to solve how to solve for x and y simultaneously, but indzaba yami beyila kakhulu on how we can simplify this one, since on our previous one we were working on how to solve for x and y on when they are on the exponents, but and on our previous one again we were working on how to solve when the x is under the side. So I saw it here, it includes both contents which we did, so I wanted you to understand this part of it. I know solving simultaneously is very easy for my maths pros, for my lovely, smart, handsome and beautiful maths pros. So yeah, anything you don't understand, just comment. Please subscribe and follow for more content, so that your favorite uncle can continue making some content so that we can enjoy maths. Please like and subscribe and follow for more content. Thank you.